All right, let's look at the homework 15.6, problem number 7. All right, so we want to find the surface area. All right, here. All right, first we need to look at the region on the xy plane. So let's see. So here's the equation here. And I'm gonna start rewriting a little bit. So this is going to be x squared. And I'm going to subtract ax from both sides. So you have minus ax. And then plus, let's see, y squared is equal to 0. Right? So I'm going to complete the square. So what we're going to do is I'm going to need the third term. This is always going to be a coefficient of x. You divide by 2 and square that. So we need plus a squared over 2 squared, so 4. So we need to add the same thing to both sides so that we don't change anything here. All right, we got that. All right, so then by completing a square, we have x minus, half of that would be a over 2. Then we have a squared. So that takes care of both those three terms. Plus y squared is equal to, all right, so the radius is going to be a over 2, right, then squared here. All right, so if you sketch the picture, this is what it's going to look like. All right, so you have x-axis here, and the y-axis right here. Right, then the center is at a over 2 comma 0. So here is a over 2, and here is a, right? So a over 2, so that's the center. And the circle is, the radius is a over 2, so this is the circle we're looking at. All right? And the polar equation for this is going to be, right, so you have x squared plus y squared, so it's going to be r squared is equal to a times x's r times cosine of theta. So we can simply divide through by r, so we get the r is equal to a cosine of theta. All right, so this guy has equation r is equal to a cosine of theta. All right, so let's try to find the surface area. So first, I'm going to here, I'm gonna rewrite it. I'm gonna put everyone else other than z on the other side. So it's going to be z squared is equal to a squared minus x squared minus y squared. All right, then we can just take the square root. All right, so you have z is equal to, all right, since we're looking at the above the xy plane, so we only look at the positive one, square root of a squared minus x squared minus y squared. All right, so this is going to be our f of x comma y. All right, so let's find f partial derivative with respect to x first. All right, so it's a 1/2 power, so it's a 1/2, right? Keep the same quantity, a squared minus x squared minus y squared, and subtract 1 from the power, so it's going to be negative 1/2 power. Then you would have to multiply by partial derivative inside with respect to x, so that's going to be negative 2x. All right, so we can cancel 2 on top and 2 on the bottom. So you will get, let's see, so it's going to be a negative x over square root of a squared minus x squared minus y squared. All right, and if you find the partial derivative with respect to y, right, and I'm going to actually skip some work. So since the x and y are symmetric, so it's going to be negative y over square root of a squared minus x squared minus y squared. So we're going to get that. All right, then if you compute the integrand for the surface area, right, so you have, let's see, we have to square partial with respect to x squared plus partial with respect to y squared plus 1. All right, so this is going to be, all right, so you have a square root, all right, partial with respect to x squared would be x squared over a squared minus x squared minus y squared plus, right, y squared over a squared minus x squared minus y squared. Then we're going to add 1. Right? This is going to be taking the common denominator. So we're going to get, let's see, we have a squared minus x squared minus y squared. And we have a x squared plus y squared. And a 1 is going to be, so we're going to have a squared minus x squared minus y squared over a squared minus x squared minus y squared. All right? Then we can cancel a bunch of things here. So x squared minus x squared, right? Y squared minus y squared. So we're going to get this. So a squared in the square root, so you're just going to get a over square root of a squared minus x squared minus y squared. All right, so we got that. All right, then we want to integrate it. So we want to find the surface area S. It's going to be a double integral, right, over this disk D. I'm going to call this guy D. And then integrand is going to be a over square root of a squared minus x squared minus y squared and dA. All right, so this would be the surface area. All right, so it's probably better to use the polar coordinates since we're talking about a circular region. So let's convert it to a polar coordinates. So you have double integral. All right, so a is still a over square root of a squared minus x squared minus y squared. Actually, we have to rewrite that, right? So since x squared plus y squared is r squared, so we can write it as minus r squared. All right, then area element is r dr d theta. All right, then we have, so let's see, so for fixed theta, you can see that r is going to start from 0 to r equals a cosine of theta. So you can see that this is going to go from 0 to a cosine of theta. Then what we need to do is we just need to go from negative, let's see, angle would be, going to start from here. Oops. So angle would be theta is equal to negative pi over 2. all the way to theta is equal to positive pi over 2, right? So that way we can swipe the entire disk like this, right? All right, so we're going to go from negative pi over 2 and a positive pi over 2. All right, so we got that. All right, so let's go from here. All right, so in order to compute this, I think I'm going to use a substitution here. All right, so we're going to do let u be a squared minus r squared. All right, this will give us du over dr is negative 2r. Right, then take the reciprocal both sides, so dr over du is equal to 1 over negative 2r. All right, then we can just multiply through by du, so we have a dr is equal to du over negative 2r. All right, and also we need to do the upper limit, lower limit, and upper limit. So r is initially going from 0 to a cosine of theta, right? So this is going to imply u is going to go from, if you plug in 0, so you have start from a squared, right? And then r is a squared cosine squared. So a squared minus a squared cosine squared would be a squared, actually sine squared, right? All right. So this integral is going to become this. So you have, I'm going to leave outside integral as it is for now. All right. Then I'm going to have an integral from a squared to a squared sine squared of theta. All right, then it's going to be, we decided to call this guy inside expression inside the square root u. So I'm going to actually write u as, let's see, so it's sitting on the bottom, so negative, with the square root, so I'm going to raise it to the negative 1/2 power. So we have AR still there, so I'm going to leave that. But the dr is equivalent to du over negative 2r. Right, then we have a d theta still. Right, so we have that. All right, so then we can cancel r on top and r on the bottom. And also, I'm going to incorporate this negative sign to switch the upper limit and the lower limit. So this becomes a squared sine squared of theta, and the top one becomes just a squared. All right, then also we can place a and the over 2 is just a number. So I'm going to just take this guy and take that guy and put it outside. So I'm going to, maybe I'll scratch that out. Then I'm going to put a over 2 outside. All right, so this is going to be, all right, a over 2 is just a number. All right, then we have an integral from negative pi over 2 to positive pi over 2. All right, antiderivative of this guy is going to be add 1 to the power. So it's going to be positive 1/2. Divide by 1/2 is same thing as multiply by 2, right? Then you're going from a squared sine squared of theta, and then you have a squared, right? Then we're going to have, let's see, we still have d theta. All right, then we can cancel. There's a 2 on top here and 2 on the bottom, so we can cancel those numbers. All right, then we plug in. All right, so I'm going to go here. So a is still out there. All right, integral from negative pi over 2 to positive pi over 2. Right, plug in a here, so you're going to have a square square root, so it's going to be just a. Right, minus, right, plug in a square sine square, so you're going to have a here, and a is positive, right? But here you have a sine square, so this is going to be actually absolute value of sine of theta, right? Because sine could be negative, right? So we have that. All right, then if you look at that, and so this is d theta. Oh, hold on. All right, so I'm gonna go up here so that we have more room to write. All right, so I'm gonna do this since it's going from negative pi over 2 to positive pi over 2, but the a minus a absolute value of sine theta is an even function because of the absolute value sine. I'm gonna actually go from 0 to pi over 2. Then I'm just going to multiply by 2, so you're going to have 2a, right? Then we're going from, also it's a is in common, so I'm going to just put a squared, right? Then you're going to have 1 minus sine of theta. Right, I took the absolute value sign off because since I'm talking about between 0 to pi over 2, sine of theta is always going to be non-negative, so we'll be fine. All right, so find the antiderivative. So you have a 2a squared. All right, antiderivative of 1 would be theta. Right, antiderivative of sine theta is going to be positive cosine of theta, and then you're going from 0 to pi over 2. All right, so this is going to be, right, 2a squared, right? Then you plug in pi over 2, and the cosine of pi over 2 is 0, minus, plug in 0 is 0, plug in 0, cosine of 0 is 1. So we have that. All right, then I'm going to actually just distribute 2 to get, let's see, so 2 cancel out. So you have a squared and a pi. Then I'll distribute 2 to 1, so it's going to be negative 2. All right, so let's type it in. So we got a squared times pi minus 2. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.